Hi, good day, everyone. So, welcome back to the Docker series. The journey of understanding, journey of exploring the Docker in a more deeper manner. So, let's get started. So far we have discussed many things. I mean, we have gone through many things about Docker. We have started with the introduction of the Docker, and then we have seen like how we can build the Docker container. We have also seen like how we can containerize our application. And in this session, we are going to discuss about like how to create an application image in Docker. Basically, whatever applications you have, you want to containerize for that application, how you can create the image of that application. We are going to discuss in this session, and we will further looking to the answers of the questions which will help us to explore Docker uh, deeply. So let's get started. First of all, we have here like what is Docker image or Docker file. So let's take a look into it. Although we have already discussed this previously, but uh, in this session, I mean, we need to understand Docker file and image in order to create an image of the application. Okay, so we have to uh, see today how we can create a Docker image. Creation we would see of our application. I mean, we have already seen like how we can host application in Docker container. The only thing is, in this tutorial, we will be seeing creating an image of this particular application that we have. So, what is an image? We had, uh, already a discussion on this, but technically, we want to understand what is an image. So let's understand Docker. Again, this is also we have discussed. Technically, Docker, sorry, container we have already discussed. So technically, container is just a process, right? And this process needs resources, right? What are those resources? It needs file system, right? It needs system level dependencies, right? In order to contain an application, right? It's an environment, right? So we need to tell what uh, sort of environment we want to, what sort of container we want to construct. Uh, would it be a Linux container? Would it be a Windows container or Mac container? And what all things you need to, uh, uh, run your application. All this information container needs to know. So where this information come from? From where container gets the info about the sources which we have just discussed, right? So answer to this is an image. So image is an input to container and is a descriptive file called Docker file. And this Docker file will have instructions. Okay. And these instructions will decide the type of container. What all things container needs to hold, this descriptive file decides. So for example, let's say I want to build Ubuntu container, right? I want to install Java. because my application which I want to contain into this, or the image of application I want to create into it, that application needs Java, it needs Maven, it needs Git, right? So all those information I would tell this information to the container using the Docker file. And this Docker file will help us creating an image of the application, right? So uh, this is one thing. Another thing is Docker images, our application images can be created in two ways. One way we have been, already discussing, that is the CLI. Using CLI, you can construct, you can create images, application images, your application images, right? And another way is, the second way is Docker file. We can use Docker file to create images. Okay. So these are the two, prominent ways of creating uses. Not prominent, I mean, whatever, I mean, so far, what is being used. And most prominent way is the descriptive file, this Docker file. CLI will only help you to see, I mean, if you have a good grasp from CLI, you can see what's going on with the images. You can easily explore if any issue comes, and it would be pretty much help you, as if you have a, good command on the CLI perspective of the Docker. I have been telling this from the beginning of this session. So this is another way. And in this session, we are going to take a look into both ways. I mean, first we will create images using CLI, and then we will create the Docker file. Right. So let's take a look into CLI perspective of creating images. So let me just bring up my shell up, right? And then I'll get into the Git, and then I'll get into the Docker container. I'll check what all container I have open right now. There is no container in the system. I'll check what all images I have. How do I list the images that I have in my local system? The command is docker image ls. So you see there is nothing in here right now. So I need to create a Docker container first. So you already know, like we have Docker run command for that, and I'll just give a name of the container here. I would say it would be Linux space container, right? And then I'll say I need to have interactive board, and I need to host on the port. We are already aware of this command. We have seen in previous sessions. I'll be going a little quick over it, so please don't mind. If you don't know, you can always go to the previous session and take a look into it, how these commands are working. I have explained there little detail over there. Uh, Now we need to pull what image I need to pull. So I need to pull Ubuntu image, since I want to build Linux containers. So it will start building the images. Right. So I just got into the shell here. So in this shell, you see, first of all, I'll just say update my package manager APD update. So we are already aware of it. So let it update everything. Okay, so it has updated the package manager. Let me just let just give me a moment. Let me just upgrade package managers. Again, this we have already seen what all these things are. in previous videos. So I'll just say upgrade and it will just upgrade package manager. I'll press yes. Okay, so package manager is also updated. Now Linux container is up. I would come out of this container. I'll press Control Z, Control C, and let me check my container. So for that we have Docker PS and you see container is up. And I also want to see what images I have in my local system. So it will pull Ubuntu image. So you see Ubuntu images I have here. So now let's say if I want to, create a Linux base image in my local. So right now it got downloaded here. So I want to create my personal Linux image in this system here. How can I do that? So let me get into this container again. So for that we have a command called linux exec, and then we have to tell like work directory, and then we need to tell work directory we will keep it as root, and then we would say user. So user we would say it's a root user, and then give I need to have interactive mode. So I'll say IT, and then I'll give the container ID here, and I'll have to tell what is the shell name which I want to bring. It's a bash. Excuse me, sir. Okay, so I just got into this container. So uh, let me install Java into it. No, hang on a sec. We wanted to create the Linux space, right? So we don't need to get into this right now. I need to come out of this. So to create a Linux space, we need to commit the container, whatever we have, and uh, for that we have a command called docker container and commit -m, and I would say edit Linux space. So whatever thing we are doing, I'm just creating an image of that. So right now I have just installed the Linux into the container. So I'm just, trying to make the image of that container of Linux image in my local, and then post that I don't have any dependency on that container. I can delete that. I can delete this Ubuntu image, and I can always use this image which I already have in my local. So Linux space, I have added this comment here like git command, right? How do we do the commit? So it's the pretty much same thing. Now I need to tell what is the container from which I want to, create the image. So this is a container ID I would give here. And then the name of the image which I want to, we want to give it a name, right? So name I would give as Linux base image. So if I hit enter, it should create an image. So you see it has just created an image. How do I verify it? So again, in order to check the image, we have docker ls list. So you see this, it has created this image, right? And if I have any container running, I can just delete that container. Docker rm hyphen, and then I can use this container ID. I have deleted this container. Now what I will do, I will build the container using this image. I don't need Ubuntu image, so I can also delete this image. So to delete the image, again we have docker image rm, and then the image ID you have to provide. So the image ID this is the image ID. I'll just copy it. I'll just remove it. See, it got removed. So if I have to check again, we have docker image ls, and see there is only one image is there. So by using this image, I can build container. And now in that container, I would, install Java, and then also I'll create a Java image. So I keep stacking the images on the top of each other, so you would understand the layering part. So if I want to see the layering here, so the command for that is images. I would say history, and then I'll give image ID here. So in this image ID, it will tell me like what all layers has been added to the image. So you see, it added the Linux space, right? So it added the layer here to this particular image. So if we go back to our slide here, we have already, I've already explained you the layering part of it. Okay, let's take a look into the layering part once again here. So, the image, the descriptive file with instructions into it called as Docker file, right? It has instructions. Instruction 1, instruction 2, instruction 3. So all this instruction will create a layer. So why this file? We know that this file will help us to create the image, to build the image. Okay, not only of our application, but any image you want to create. Let's say you want to create Linux image, you can use this Docker file to create it, or you can use CLI. I've already CLI. We have been seeing that. Just previously we have seen the CLI. So here I'm just trying to explain you the layering concept of the image actually. So this Docker file will have instruction 1, in the instruction 2, instruction 3. Each instruction will be stacked or stored as a layer 1, layer 2, or layer 3. And these layers, once created, cannot be modified. Once created, you cannot modify it. And this is what makes images immutable. See, images are immutable. What does that mean? So, in Java, strings are immutable. If you are aware of that concept, it's a pretty much same concept here. Instead of, string pool concept, constant concept, it has its own file system, right? So in container, it has union file system. So we will discuss this in later videos, union file system. But for now, I just want to explain you images are immutable. Why images are immutable? Whatever, delta. Delta means change in image info, or any modification to the image will be added as a separate layer. Will be added as a separate layer. Okay, and this layer can't be modified, and that's what the immutable. That's what making images immutable. So, for example, let's say if I have created Ubuntu uh, container, this will be uh, stacked as layer 1, and then on the top of it, if I install Java on the container, this is again now image. Till now image had only Linux into it. Now I installed Java, so see, image is modified, right? So every modification, all delta, you have seen the differentiation in calculus, right? Why do we have differentiation? We, in scientific application, we create the delta, right? Let's say if I am moving in circular path. Each circular path, a very change in direction will be created as delta. So same concept here. Any change, we call it as a delta here, and that delta will always create a layer here. Okay, and then here it will create layer 2, layer 3 if I install Maven, right? So this is what the concept of images being immutable and the layering concept. This is what we call image layering. And how do I see the how do I can see the you know image layers? So for that I have shown you the command called docker image ls, and you see these are the layer docker image, not ls, history, right? So in image history, then I have to tell the ID of image, what image I want to see, or name of the image. So it just showed me the history, like this image, latest change. We just added the Linux operating system on this image. Again, let me see how many images I have. I have only one image here. And this is the image. So let me just try to install Java into it, and all the further dependencies like Maven and Git, and then we'll see the image layering stack, how it's being built here. So let's get into the container which we have created. I don't have any container. Okay, we have just deleted it. Just give me a moment. So let's build a container here real quick. So I'll give name, and then we'll say uh, Java hyphen Git hyphen Maven hyphen uh, Linux container. So basically it will tell like this container will contain Java, Git, Maven, and Linux. So again, I have to give interactive mode, I have to give port, and then I would use this image, Linux base image this time. See, it has created container immediately. So I am inside the container now. Let me, update the package manager. I'll say apt update. Right, it has updated. Then again, I would say apt upgrade. It would update the package manager. I would say apt install Java. I have to say open GTK. First, we have to search for it. So I'll just go up, and I'll say apt install open GTK. So it has started installing GTK. It would take some time. Let's give it a minute or so. Okay, so looks like Java is installed. So I'll just quickly check here. So you see Java is installed here. Now what I have to install, you will install Git here. It will also take some minute or so. It depends on the network speed you have. We have already discussed and seen all those things. Why I'm doing it, I just want to show you the image layering part of it. That's why I'm doing this installation. Again, we'll just create an image. You will see the layers, and that's what this exercise is all about. Okay, so Git is also installed. I can see the version here like this version. And then I need to fetch Maven. So again, so yeah, finally we have installed Maven as well. So we can check by using, so we have got Maven into it, right? So I have created Git Java Maven image. I haven't created image, but this container has all these, application dependencies into it. So how do I create an image out of it? Let's come out of this container first. So I just came out of this container. Let me see container status. So it is up and running. Let me see image status. I see only the Linux based image I have. So I have I have to create this Java Git Maven Linux image, right? So for that, we need to commit this container as an image. Whatever thing we have done in this container, we have to commit that. And again, it's the same thing. If you are aware of Git command, it's like commit m, and I need to give comment here what changes I did, what is the delta. So I added Java, comma Git, I added Maven and Linux we already had into it. So I'll add this comment. So what is the container in which I had to, save the commit? So this is the container ID and I can give a name to the image. So I would give this image a name called Java Git Maven Linux image. And if I click enter, it will build an image. Whatever the commands I have used here, all those things I'll just jot it down. I have already jotted down in the previous session. I mean, must have seen in the slide, but at the description of the video, you would find all these details, whatever commands and all the keynotes of the session. You can always fetch that information from there. Okay, so let's check the images. For checking the images, we have ls. So you see this image has been created. And I don't need this Linux image now. I can delete this. And for deleting an image, again, we have docker rm, and I need to tell the image ID here. Saying, see, read the error here. It is saying unable to delete images being used by running container, which is very right? Because we already have a container which is running this one, and that container is using Linux base. So what I have to do, I have to stop this container or I have to delete this container. I'll just say rm hyphen f and then I'll just give this container ID and I'll just paste this image and you see, sorry, this container ID and this container will be deleted. So I won't be having any container here. I can say ps hyphen a. So you see there is no container here. Now if I list in my images, what all images I have, so I have to delete this image. I can easily delete this by using docker image rm. I have to give the ID of this image and it will delete this image. So if I do docker image ls, I only see this latest image which I have created, right? And if I want to see the layers, what is the layering part, all the changes happened to this image. So for that, I have a command called docker image. I can see the history of this image. And I would just have to give the image ID or the name of the image. You see, this is telling, first of all, we added the Linux base to this image, and then we added the Java Git Maven Linux to this image, right? So what is the advantage of doing it? Why I am doing it? I have created this image. What is the advantage of doing it? See, the advantage here is let's say I did not have any image in my system. It was just a fresh bare bone system. So what I had to do, I had to, pull Linux image first. Again, it will go and fetch all those things. It will take some time to download the image, right? And let's say this ubuntu image I have to use in another container, so again and again I have to download the stuff from the linux, right? So whatever the common thing that I have to that I needed for my application, I can always create an image of that uh, common things, and I can leverage that instead of downloading again and again. So as you can see, when I was installing Java, it was taking so much of time. I mean, I was installing Git, Maven, Linux. It took so much of time. But now you see, I have this image created. Immediately, it will be building up the container. I don't have to download it again and again, these system level dependencies. So any application which are using this Java, Git, Maven, and Linux, as a platform, as an infrastructure, so I can always use this image instead of creating a fresh image for Linux and then doing the all old school stuff. So uh, now let's check what container we have. We don't have any container, right? So I'll just build the container by using this image, and it will be real quick. I don't have to do anything. So Docker run, and then we know, like, we have to give it a name. So again, it's a container, right? Right. And then we have to tell I need interactive shell, and I also need a port where I want to host it. I'll just tell the port, and again I need to give the image name. I'll just copy it from there and see, it will be real quick. See, in a minute I just got into this shell, and if I see Java version, it has already Java. I don't need to install Java. If I need to install Maven, it's already have a Maven into it, so I don't need to do anything. You see, it told me Maven. Git also, similarly, Git is also there, right? So do you see what's the advantage of doing it? Let me come out of it. So I just came out of it. See, again, I'll show you the image that we have. So now I have an image. Just give me a minute. Excuse me, sorry. So now just give me a minute. So I have this image, Java, Git, Maven, Linux. That means these all dependencies are there in this image. Let's say I want to create the application image, right? The application which we saw uh, day before, days before yesterday, right? So let me just show you what that application was. So let me come out, right? Just give me a minute. Let me come out of it, and we'll see Alice. So I'll just get into this application com.m.platform. Let's say I want to create the image of this application. First of all, let me try to build this application. Sorry, it has started scanning. I'm doing it in my local, but now we will see how we can create an image of this application. And moving forward, I just have to use that image, and this application will be building automatically. Right? The same thing I have to, let me come out of it. So same thing I have to do, I have to create the image of this application. So in order to do that, let me see what all containers are running. This container is running. I'll just delete this container. Or I can leverage this container itself. Let me just get into this container. We need exec, and then we have work directory. work directories, and then we have user. User is root, right? I'll just tell the container name. And before that, I also need to tell like bring the interactive cell up and the shell type. I would use bash. I just got into this container. I'll add further layers to it. I'll just install this application. So for that, I need to do the cloning. So I would say git clone, and I'll just enter this URL. It will start cloning it. So once I create the image of this application, I don't have to do this cloning again and again. Latest pull we might need to do, but this cloning I don't have to do again and again. So, but before that, let me check the directory structure. See, it got pulled here at the root, so we don't want to do that. So what I will do, I'll just delete this. And if I do this here, I just create a separate folder here, and that folder is git, and I'll just get into this folder. In this folder, we will do the cloning. Right? We got, so I mean, if I do ls, you see this folder here. I'll say I just got into this application. I would say Maven test compile. Sorry, Maven clean compile. I won't say test because test won't work. We know the reason, because it's a Linux platform. Application has been developed in Windows. We need a fixes in order to have it running in the Linux operating system. We'll do it in later, but for just for the sake of understanding, let's give it a compile so that build passes. So it started downloading everything here. It's the one-time activity. If I make an image of this, it this downloads again and again. I don't have to do it. So that is the advantage of creating an image. So I hope this exercise is helping you to, build an application image. I would, share the keynotes of whatever things we are doing in the CLI. All the comments I will jot down and share it with you. You can always find in the description of the video. So don't worry about that if you don't see anything. I mean, noted here. I mean, all those notes, keynotes, comments, everything in detail you would see in the description of the video. So you can always take it from there. So it is started downloading the, building the project, and sooner we will, just build an image of this project and we will save it. Like we saved the Java Git Maven image. So then we don't need to, we can avoid all those things, duplicate downloading again and again. It's just a matter, it will be just a matter of git pull. So this is how we can build application image using CLI. Now we will shift our focus to build an application image using the Docker file. So you see build success. So we are all set. Let me come out of this. I'll say Control Z. So I just came out of it. Let me check Docker PS. So it's the same container I have. I'll say Docker image ls. I have only one image, right? So I can save. How do I, save this container? Uh, as an image, container, modification, whatever I've made as an image. So simply we'll do the commit. So if a container, right? So we do commit and then hyphen m. I would add, what did I do? So edit com dot m platform dot framework application, right? And which container is that? This is the container. What is the name I want to give to this image? So name I would give this application image and platform application image. I would give, I would hit enter. It would create an image, excuse me, sorry, of this application. See, it has created image. How do I check it? See, I got this my application image here. So now I don't even need this image because already I have this image in my local. I can always create, use this image, whenever I want to run this application or whatever modification I want to do. If I want to see what all thing, the layering part of this image, so I have to say image history, right? And this image history, I can give the name of this image or image ID. You can give, you see it, it has just telling, it is telling me what all thing has happened to this image, you see. First of all, we added Linux space and then we added Java Git Maven to this image and then we added com.platform application on the top of it, right? So let me remove the container. Where is the container? This is the container here. I've just removed this container. Do I have any container running now? No. Let me build container using this. See, it will be really fast actually. I mean, that is what another advantage of, using Docker images. So all I have to do Docker mm, run here and again name I would give m platform image, right? And then I will say hyphen is get me the interactive shell and I have to tell the port number, right? And I have to give the image name from where I want to build. See, this time I am not using Ubuntu, Linux, anything. Already this container has, this image has everything. So you see, I just got into it. Everything which I need to build this image or build this application, run this application, everything is already there. All I need to do mvn test compile, it will, sorry, mvn clean compile, it will fail. See, it has failed. Why? Because I have cloned this in my Git repo. So I need to get into this. I see where is my application. This is my application. I'll just get into this application, right? Now, if I do here Maven clean compile. So you see, we can avoid the business of downloading everything dependencies again and again, all those, long story, we can always make it a short. We can always curtail it by using images. That is the advantage of images, right? So this is how we build the images by using CLI. So just give me a moment. So if you uh, let me come out of it. So if you see, I have already built a container Docker PS. You see, This container is up. It was so fast. I mean, if you see the images, I don't even need this image. I can delete this, but I won't delete this because this is the base image. Many of the projects will use this image. You can similarly, create image for the your application stuff. Let's say if you are using Node.js as a server, you can create an image. You are using Node Package Manager, npm. You are using NodeMon. You are using whatever new technology you are using. You are using Golang. You are using C++. Here you can create an image and you can always store it as a base image here, so that you can always leverage this image to build your application. It will be very much faster. So instead of doing everything from the scratch again and again, you can we can always create images, and I can also push this image to the repository Docker Hub. We have discussed this previously, and from there, in the future projects, I can always pull it and attain my alternatives, whatever we needed, as per the requirements, as per the project, or as per the your business applications you're working in. So we have seen how we can build the images using CLI. Now we will, we are gonna take a look into like how we can do the same stuff using Docker file. So now we will discuss like how we can create the application image by using the Docker file. Basically, the same step that we have done. So let me just jot down here, right? So we already know. I have already, I mean, explained you many times. Like Docker file is just a a series of steps, or the number of steps, or the commands we write, and those commands will help us to create an image of an application. Command one, command two, command three, right? So this is what Docker file is. Now, before even getting into the how do we create Docker file, and how do we write Docker file, there is something called Docker file instruction. Okay, so we need to know this instruction set of Docker file. So when I say there is lot many things here to to know in this Docker file instruction set, but we would be focusing only on the basic instruction sets. Okay, which will help us to build whatever thing we have done through CLI, like how I showed you to build the application. Same thing we will be doing here. So basic Docker file instructions you would be needing. Although there is many things out there to know about Docker file instruction, there is a whole manual in place. You can always pull it up and you start reading that, understanding that, and uh, leverage it as per the need of the application. So, but for now, basics is something which we need to know for now, which is very important. So, first thing, if you jot down the steps, right? What did I do very initially when I was in, right? Let me not jot it down here. So, in CLI, what did I do? The first thing I have just pulled the image, pulled the Ubuntu image, right? And build a container. And for that, I've used the command docker run. I set the working directory, work dir, right? I said it will be root. I set the user. I said it will be root user. I set the interactive mode of the shell. I said I wanted to have an interactive mode. Then I set the port. I said it will be 8080. And finally, I gave the image name which I want to build or mount. Right. So this is the image I gave. right? So this is what I have done when I, pulled the image actually. Same thing I need to do, uh, you know, uh, when I write a Docker file. But before that, let me jot down all the things. Then after, what did I do? I just got into the container, Docker container. How did I do? I just got the Docker shell. I just got into the Docker shell. And inside the Docker shell, I updated package manager apt update, apt upgrade. I ran this command basically. Then I just apt installed git java and many things I have installed. I have installed maven, right? So after installing, what did I do? I created git folder, right? Mkdir, right? Then after I got into the git, this folder, I said cd git. I went to this folder structure. And here I cloned the repository. I did the git clone. Your repository URL, whatever you have mentioned there. And then I again got into the cloned repo, right? And there I ran the command maven clean compile, right? These are the series of steps which I have done via CLI. Now, same step I have to do using same step I have to do using Docker file, right? So we need to understand basic Docker file instructions. So one is there is a command called uh, from. Always command starts from, and from tells the image, which image you want, what is the base image of the container, base image of the container, from which container will be built. I mean, images will be built. Final image will be built, I mean to say. Base image. So we said Ubuntu right through CLI. So Ubuntu is a base image. So I would always use from. So it will start with the from. Second thing, in the command, I have to set the working directory, right? Working directory I set as root, right? So working directory means in the root always, this point is important to note. In the root, always whatever command you're gonna run, right, inside the Docker shell, it will be running into the root path. Here in the root path, it will be running the Docker command. So Docker command will be running in root until you change the directory. Okay. Now, what did I do? I just created this how do I set the port 8080, right? How do I set the port? So for that we have a command called expose, and you mentioned the port number, right? You remember if you remember the CLI command and hyphen p 8080 I was giving. So same thing if I have to do using the uh your Docker file, I need to use expose instruction set, right? And then in the Docker shell, I was using apt upgrade or update, or any system dependency Java I was installing. So in the Docker shell, if I want to run anything, we have a run command here. So you can use run command and you can add your commands here: apt install maven, and you can always use ampersand and operator to append the commands here, right? Fifth thing, I added the root user, right? So for that we have user instruction set. You can always set user if you want. I set it as root in the instructions. So you can use user for that. Six instruction set that we have. If you remember, sometime when I come out of the Docker shell and I want to run a particular command outside the shell. So for that we have cmd, and the syntax would be like cmd, and in the square bracket you mention the command whatever you want to do. Let's say I want to do mvn clean compile. So this will be the default command. Whenever this image will be built, it will run this command as a default. Whenever if you have a cmd in your descriptive file on this docker file, right? And then there is something called copy. Excuse me, sorry. Let's say if you want to copy something or every file from your local file system, you would be using dot. And if you want to copy it into the wherever you want to copy it into the Docker file system, you would say dot. So it will be created to the root, or you mention the path. You mention the path where you want your files to be copied. So you would use copy instruction for that. Or something like if you want to set the environment variable, so you can say env, and it will be set as the key value pair in the curly braces, or like backtick operator we have in javascript, right? So in these braces you can set your environment variable, very important while setting the secrets. So secrets, if you don't know, I mean, secrets are the let's say if you have a password and username, we just don't write it like this as simple in the plain English language. So we will always use encrypted language to mask our password and username. So for that, GitHub has provided a feature of secrets, so it will automatically create the secrets and store it into the GitHub repository itself, your code repository itself. So from that code repository at the runtime, if you want to fetch the secrets, you can always add them into your environment as an environment variable, and you can pull them out by using dollar and this dot operator as a key value pair. Sometimes that depends totally. So these are the there are many instruction set. I mean, we would not be able to cover everything I mean in this short tutorial, but for now these are the basic the instruction set we should be aware of. So this will help us to write down the docker file for our project. So just give me a moment. So there is now one more thing which we would need to discuss here. So we have seen the descriptive file, I mean Docker file, how we can write the instruction set, basic instruction set. I would be writing the Docker file. I mean we would see as a demo here live, like how do we write it. But before even getting into it, so there is something called, let's say if I have to create a this Docker file and I mean, automatically for my project. So for that, we have a command. So basically, how do we create a Docker file automatically for our application? So for that, we have a command called, like, let me jot down here. How do we, create Docker file automatically? So for that, we have a command called, Docker init, which you need to, do it when you are inside your application, like you do the git clone and all, right? So how do you do that? You just go to the get inside into your repository, code repository for directory, and from there you start running this command. Similarly, you from there you need to do the docker init, and this docker init will create a file like your three files. Basically it will create docker file which doesn't have any extension, it's just a docker file. It would create your docker compose file also. I mean docker compose file it will create, which has a extension of yaml file, right? And then it will create the docker ignore file. What is docker compose? We have already discussed. I mean uh, just for the fraction of moment we have discussed in the previous videos. Docker ignore, what it is, we will be discussing this thing in detail, but for now I'm not discussing it because that is not the ambition of this session. So Docker file is first what we need to focus upon. So that's what the Docker init is all about. There is something called Docker build actually. So to build a image from your Docker file, we use Docker build, and if we use dot, you know, give me a moment, please. If we use Docker build dot, it will immediately start building the image by using this Docker file, right? And then let's say if I want to give image a name actually. So for that we have a command called Docker build. There is something called tags, and you can give image name over here, right? So this is what this command will create an image with this image name. So we need to be aware of these three thing. I mean, I've just told you for your information purpose. You can make a note of it. Anyway, I'll be sharing keynotes of this session uh, in the description of the video. And Docker build, we will be discussing in little detail in this session. We have already discussed previously, so but not now. Uh, we should be focusing upon the our project. How do we create the Docker file first? So let me just get into the project that I have. See, this is my application, the same application that I have here. So for this application, let's say if I have to, create the Docker file here. So how do I achieve that? So let me get into the shell of it. So let me come out of it. I'm in Git. I'll do dir. I will do Docker cd, and then I'll just get into this platform, right? com.m platform.prim. And then from here, as I told you, like you can do Docker init, and this init command would initiate your Docker files. It will create three files. Uh, the moment I hit enter, it started asking question like, do you want to overwrite them? It is saying, it looks like it is already filled. There we can say yes. So it is asking which application platform does your project use. So it's Java. I'll just hit enter. Send what is the relative directory? It's dot source only. I'll hit enter. And what is the version of Java we want to use? I would say 17. And port in which you want to listen, that we would say 8080. So you see, uh, it has already created this Docker files and everything is it. You can see here it is saying created Docker file, Docker ignore, Docker file compose.file, and readme.dockerfile.md. So yeah, it has just created it. Let me refresh this thing here. So you see, I have got Docker file created here. So it has so many instructions over here. I don't need it because we want to create our customized Docker image or Docker file, for which the way we have, did it in CLI, same thing we want to achieve with Docker file. So we will write our own, Docker file set. So I have just removed it. So what is, let me pull out this slide. So what is the first step? First step was pull the Docker image, right? So I would just write it down here, like from where I want to pull. So I would say from, and I would say Ubuntu image I want to pull, right? One more thing here. So right now I'm into this, right? Let me come out of it. Let me get into the Docker, and we have, if I say Docker image ls, I already have image of this platform. I can directly use this. I can avoid all the business of, you know, writing this Docker file again. But I won't do it because you to, I want to explain it via Docker file. So let me just delete this image for that. So from here, for that, we have a command called Docker, and then image we would say RM. And we need to give, either you give the name of the image. I would give the name of the image. Let me give space here. Oh, it is jeopardizing the whole. No, yeah. I have just deleted. Okay, let's understand what it is saying. Just give me a moment. See, some container is using this image. So let me check which all containers are running. See, it is not the, something like stagnant data, or sorry, static data, that it's a very dynamic thing. You need to be into the aesthetics of a command line to understand what's going on. And, you should be able to figure out how to, tackle, understand the errors, how to do fix the problem. So see, this container is running right now. So all I have to do, I'll just delete this container from here. So for deleting the container, I just have to say Docker, and then we have rm, and then we have hyphen m, and then we will just use this image name, or you would use this container ID. So this is deleted. If I say Docker ps, nothing is there. If I'll do Docker image ls, this image is there. I'll delete all the images. I don't need any image, so that we can, see from the scratch. So I would say Docker image rm, and I'll just give this. Deleted. So if I'll do Docker image ls, nothing is there. So now we are all set. So we will do everything that we have done from the CLI. We will do via Docker file. So here, from which image I want to pull, I want to pull Ubuntu, right? Now, next instruction, once I get into the Ubuntu, I need to, where is my PPT? Just give me a moment, please. There are so many things are opened here, so sometimes the windows get lost. So I need to focus on bringing it back. So yeah, this is the first step. We have just attained it. Now I just got into the Docker shell, and in that I need to run this command apt update, apt upgrade, right? So for that a uh, we have a instruction called run. But before even getting into this run, so in the CLI, if you see, I whenever I used to build the container, I used to say like work directory, right? We used to say work directory, and we used to set it as root. So we can use work dir as a command, or the instruction to set the root. And same way we have to set the user. So user we would set as a root. And port number also, we need to expose the port number. So for that, we have this expose command, and we would say 8080. And now we are all set. So now I have to run the commandlet. So I would say apt get, and I would say I need to update the package manager. I would say this. And then I would use this ampersand here. Basically, I'm just appending the command line. So again, apt, I would say upgrade. Right, right. And then we need to install uh, Maven, right? So one more thing, you need to pass an argument here or parameter here. Why? So why you need to do that? Because let's say while downloading this, updating this apt package manager, there is sometimes the questionnaires or pop-up sort of thing comes up, like where you want to key in yes. So you can always say why here. And then I would say, again, I would say uh, apt install git, and I would key in y, and I would say apt install maven. I would, you know, again, I would key in y, and in next line, excuse me, sorry. In next line again, I would say I need to install Java. So I would say apt installed OpenJDK 17 we would install, right? And I would key your Y to run it. So you see here, updating, upgrade, this, all things I have done here. Now I have to create the Git folder. If you remember in the CLI, what I have done. So for that, again, run command you will use, and I would say cd git. Before that, I have to, create this Git. So I would say, and now I have got into this Git. So we can, simply use Git clone, right? And then I can, change the directory from here. So I can say, I know the file, the directory name, it will create this one. So I'll just get into this directory. And from here, again, I can, run the command like mbn clean compile Yeah, so our Docker file is all set. Let me save it. So let's see how it, let's build it from command line. So let me clear it, everything from here. And now here I need to get into this project actually. So I would say cd. So once we are inside the project, we just need to say, like we did the Docker int. So we have Docker build to build the image. And then I would say tag in order to, give it a name. So we would say M platform. Image. So, and then we have to give dot as usual. So it will start building images. I mean, image of this application. Let's see how it goes. It will take a minute or so. So basically the same process it will do the way we used to do it from the CLI. The same thing now we are, doing using the this Docker file here. Everything I have jotted down in Docker file. You can, create an image, you can give it a name, and you can always leverage this image. Next time, I mean, you can just, uh, you know, just save this image or you update your Docker file with this image, and it will do the needful for you. So you see, it has started building the application. It has done all the steps, but we have to make slight modification in this Docker file actually. So we need to mention, uh, the project or the application where we want to get into, and then we can run a Maven clean compile. So the point I'm trying to make over here is if you are, running directly like Maven clean compile here, it won't work. Uh, Even though you would add get into this CD application bundle, because by default this command will be run at the root directory whatever we set here. So this command will not run, I mean, won't work. So first of all you need to tell to the build kit actually. What is build kit? We will talk a little later. Build kit daemon to please, I mean, first of all, you just get into this directory, project directory, where we have extracted the Git repository, and from there we will run this command. And that is what is happening. You see, it has started, oh, it has successfully built the image. It has started exporting the image. You see, it has created an image, docker.io library, M platform application image. So you see, this is the image it has created. By default, it is just add this docker.io, but because that is where it is gonna store image in the Docker Hub. If you want to change, you can change it. So how do I check whether images are created or not? So same thing. If I do image ls, it will show me. See, this image has been created for this application. I don't need Ubuntu image, so I can directly delete it from here. So you can say image rm, and then I would say give it the ID of this, and image will be deleted. So if I say Docker image here again, it will be like, see, this image is created. So I can always, push this image to the, image repository, share this image wherever I want. So Docker is a container. You can ship your container anywhere. How you can ship your container? This is how you ship your container. You just share your image, this image, and that's how the shipping works in Dockerization or containerization, right? So if I see any container, no container is up right now. But if I want to, build a container from this, so all I need to do, again, we are aware of uh, Docker run, we give name, and then uh, any name you can give, you say checks, and then you can say hyphen IT and then P8080, and I would give this image name this time. It will be pretty much faster. Everything will be set up here. All I need is to run. You see, I just got into it, and I just have to check. I just need to get into the Git. I'll say ls. I'll say it is not showing, which it should have shown. We try to get into this com.m platform. This image should have created this, but it is not showing. Let me check the image. Let me come out of this container. Cloning part also it should have added, so that means something we need to fix in Docker. Yeah, cloning also it has done, but why it is not? So here, if I see our, so we have created this. Okay, so see, there is an issue here. I need to update an image. You see, I told you by default, this will, clone everything in the root of the system. So this is what is happening. So just give me a moment. So I just got into it. So if I do ls, see, it has created on the top of it. So you understood how you can debug. See, this will help us. This exercise will help us to debug our Docker file. So see what this Docker file is doing. It is just, kind of creating every command is being executed at the root of the system. So this cloning, I mean, it has just happened at the root, and we don't want to have it happen. So what we will do, we will just club this, you know, command together. We will say install this JDK, mkdir, create a Git folder, and then after we will say get into this Git repository, and then you do the clone. So I'll just append this. I'll remove it from here. So now if I come out of it, I once again I'll just delete the container. Delete it. So again, what I'm gonna do, I'm gonna build this image. we need to mention inside Git we have. So I'll just say it. Why it is failing? Because now we don't have this directory, right? This directory we have just cloned inside. Uh, we have just cloned it inside Git folder, right? As you can see here, I'm creating Git folder, and I just got into this Git folder. In this Git folder, I have just cloned the repository. So I need to cd into the Git and then this folder name, and there I need to run this command, and that is what happened, which is why it was failing. Now it will, yeah, it has started running. So these issues can keep coming, but only thing is we should be able to understand what is happening, and by reading the errors, we should be able to interpret it and fix it, and then have our build pass. So this thing keep happening. So don't be afraid of like something is not working, something is being broken. You see redness in the screen. So don't be, uh, you know, go mad about it. We just need to focus on what went wrong, and we just need to research on them and get it fixed. So yeah, you see, this time image has been built properly. So if I have to say I'll just, if I say Docker image ls, you see this image is updated. If I have to see the history of this image, I again, same thing we have been discussing a lot. Um, so you see, this is what has happened. So this image has these many changes. We are seeing all those things. And if I have to check what all no container is running right now, so what I can do, I can just I can just create a container out of it. So I can say name, and I just gave it a name called M platform image or M platform container, right? And then again, this is the same thing. If on IT, I can P, I say 40 is equal to 8080 and 80, and then followed by, I would give this image name, right? And it will build the container. See, I'm inside the container. So all I need to do is what? I need to do ls. You see, I have got git here. I just get into it. I just need to do com dot m platform dot framework, right? And here I can do mvn clean compile test view only, but only clean compile is here clean. And it was this time it was so faster. Already it has all the dependencies into it. So this is how we can build the container or build the image, right? So we have seen it like our first pipeline that we have seen here. Sorry, first Docker file we have seen here. This is how we have to keep working on it and keep, writing our Docker files based on the requirement of the projects. Let's say tomorrow you have to connect with an image which is there up there into the cloud. So all you need to do is just how do you log into the cloud? You would be given an address, the IP address of the URL of that cloud. You need to mention that. Then you need to tell the path parameters you need to enter into it each time. There is a whole structure of it. So you can read all those documentation. I mean, Docker has already shared, a good amount of documentation. If you stuck somewhere, you can always, refer it. The only purpose of, coming up with this video sessions is to give you, the basic idea of Docker, how it works. I mean, and so that, you can get along with the system. Of the Docker. But there are many things in Docker. Obviously, it can't be covered in the video session, but at least the basic perspective, we are, kind of, I hope so, we are getting along with the Docker. So this exercise should definitely help you. There are other topics which I had to cover. I mean, there was something called build kit and build X. So I wanted to discuss it, but not for today. Maybe we will discuss in next next session. But till then, yeah, that's the pretty much about the how we do the container, how we create the image, how we build the application image using CLI, and how we build application image using Dockerfile. So thank you so much for joining the session. I wish you a good day. Uh, Stay connected. Thank you.